see everyone's coming back from Wonder or for the break. So we have now an exciting session, second technical session this morning or this afternoon, depending where you are in the world, on process architectures. And we have 5 presentations, 2 are scientific papers, 1 student presentation and 2 industry presentations. So in order to keep it on time and have time for a discussion at the end, hopefully, we're going to start right away with the first one, which is from, it's Nikolai Waring, who is going to present for us. Well, I'll let you do the talking, so I won't repeat the title. So I give it a 4. So just to remember, every scientific presentation is supposed to be at 12 minutes, and then the student posters 8 minutes, and industrial presentation, and just to remember here, it's 12 as well. So 8 minutes for a student presentation and 12 for the others. So I give you the floor, Nikolai. Welcome to the conference.
Thank you. So the first author of this paper is Ali Yassin, but he has recently moved from Beirut to New York and is also engaged with a double teaching load this fall. So for that reason, he asked me to step in. But it's a joint project with Tore and myself and Ali. So my work related to the DSM started 7 years ago when I became an associate professor. I had been in management consulting for 18 years, and I decided to go into academia. And I was helped by information I received from Tyson. I sent him an email asking for references and resources, and he sent me a very long email back with several interesting references that I actually went and read, and that was very helpful. And it has led to the creation of a software tool called Reconfig that we use for organization redesign. So we use that tool to map interdependencies between roles, and we have a clustering algorithm that also suggests a better way to organize firms. So my work is related to organization design. So in other words, how to find the best formal structure of an organization, but taking into consideration, of course, the work processes and the interdependencies between work processes. So that's the brief background. And Tore and I, and third colleague Kim, we contacted Ali Yassin, who probably many of you know was a contributor in terms of algorithms in this area, to do some work with us. So we have 3 papers on the way right now. So this is one of them. So as you probably know, the main principle in organization design, if we talk about bottom-up organization design, taking into consideration the work processes, is to group interdependent roles together. So if we have, like we see here on the left, a set of roles that are interdependent in terms of the work processes, to find a way so you can cluster them so that the interdependent ones are placed in the same subunit, whether we're talking about teams or departments or some other type of unit. And the main goal is to minimize coordination costs. So this principle is, of course, central to the DSM methodology, but it's also one which you can find in organizational theory. And the first mention of it, I think, is from 1937. So the basic idea is a common one. However, there are exceptions. There are situations where one should not follow this principle. And in this paper, we're looking at one such exception. And that is when it might be beneficial to remove resources from teams or other subunits and place them in the common unit for shared services, for example, despite there being interdependencies with the roles in each unit. And this is basically the concept of consolidation. So sometimes there is a value to consolidating resources in a common unit instead of having dedicated resources in each individual department or team or whatever it is. However, from a DSM perspective, there are at least 2 challenges related to this. So one is that we have not been able to find any analytical methods that can support these kinds of consolidation decisions. And existing DSM methods simply do not take into account this issue of consolidation. So the main question for this work is how the DSM methodology can be extended to support grouping of roles into units in situations where some elements may be consolidated, or where there's a value to consolidating certain elements or roles outside of clusters, and even when there are interdependencies with the other roles in the units. So one important part here is how one can identify a potential for consolidation. And if you look at it from the perspective of main principles, obviously it has to do with the expected benefits. So what can you gain from removing resources from individual units and placing them in a common unit that serves the other units? But you also have to take into consideration, obviously, the downsides. When you do that, first of all, the coordination costs may go up, at least in two different ways. First of all, there's an added coordination cost because now they have to coordinate across a boundary. They are no longer placed in the same units as the people that they're serving. And there's also the organizational coordination cost may go up because once you have a common unit, you have to negotiate who should be able to use the common resource and come up with some agreement or principles for how to utilize the common resources. And there's also the implementation cost related to this this change. I mean, it's not free to create a new unit, and people may need training. The IT systems may need to be adjusted. You may need to have a shared services agreement, and so on and so forth. So in terms of the benefits, that one can find different criteria in different literatures. In economics, this is often called Economists of Scope, where the basic idea was that it sometimes is cheaper to produce something or two components or more components together rather than producing them separately. In strategic management, you have the broader concept of synergy, which can also be increased revenues from combining resources together. Yeah, I already covered the issue of increased coordination cost and the cost of the implementation. So this is the basic equation that we somehow need to figure out how to assess in this kind of a project. Now, some of you might think here that this has already been resolved because it is similar to the concept of a bus in the DSM methodology. So a bus is a module that has interaction or interdependencies towards several other modules or components. Another similar concept is field separation, which has been described by Carl Otto and other authors. So the idea that you sometimes need to separate components that conflict with each other due to some other concerns. So it can be, for example, high versus low voltage in a physical product. This morning, I was talking to a manager from a train operator in my country, and he said that they had to separate the organization into two different parts. One which receives subsidies from the government, and another part which competes on the open market for contracts for train services. So there's a similar kind of separation between different types of business. And another concept that I have introduced myself with a colleague is functional conflict. So when you have goal conflicts or conflicting functions between roles, they should not be placed in the same unit, even if they are interdependent. I have a whole article about that. However, as I said, these are similar or related, but not exactly the same as consolidation. And the reason is that a bus, for example, is defined based on the current task interdependencies. And that is not necessarily the case with consolidation decisions, because here we're talking about a need to consolidate roles or resources based on potential of future benefits, not on the existing patterns that you see in the DSM. And as for field separation and functional conflict, the consolidation is usually based on positive benefits that you want to achieve, not avoidance of negative outcomes, like in field separation and functional conflict. So what are the more specific consolidation criteria then that one can use to make this decision? Well, I would suggest four main ones. In the paper we describe, I would describe three main ones. In the paper we describe four, but I think these are the central ones. First of all, there is something related to the need for learning and functional specialization. So, you know, if you see that there are certain functions that are performed in different teams or units today, but you think, for example, it might be an IT person who is placed in each unit, but you see that there's a need for learning between the IT people or functional specialization, that might be an argument for consolidating these resources in a common unit rather than dedicating them to individual units. Another one might be a need for consistency in terms of methods and approaches across units. So if there's a need to ensure standardization, consistency in methods, those people should probably be placed in the same unit rather than being dispersed. And the third one is resource utilization. So if you have dedicated resources today, some that are utilized 30% of the time and some that are utilized 120% of the time, you might get more even, stable utilization by placing them in a common unit and then renting them out basically to the units when there's a need for the resource. So these are the consolidation criteria. The second issue here is how one can modify the DSM itself. I won't go through the different options because there are several discussed in the paper, but the basic idea is here. So here we take an example of a small team where you have 4 engineers and 2 IT support people. So 6 roles in total. So if you were to base the grouping based on the interdependencies alone, you would get these 2 sub-teams, engineer 1, 3 in the first team together with IT support 1, and engineer 2 and 4 together with IT support person number 2. However, if you make this assessment based on the criteria that I mentioned, the IT support people should be placed outside of the team in a common unit. So one simple idea here is to then freeze these resources that are supposed to be consolidated so they are not part of the clustering that is done with the remaining elements in the DSM. So finally, what are the next steps? Well, this is a conceptual paper with some examples. So we need to consider how these criteria are to be assessed, combined, and weighted. And that's not clear at the moment. So we're talking about different types of data, different types of assessments that need to be done and then combined into a total score somehow. We will collect and analyze some test data, maybe from a real organization or test data that we generate ourselves. And one option we're also considering is to compare our method with actual decisions made by decision makers. So we can see whether we would arrive at the same conclusion as managers in organizations when, for example, by giving them scenarios and asking them in each scenario whether they would consolidate or not consolidate the resources that are described. So that concludes my presentation.
Thank you very much, Nikolai, for doing it and also for keeping on time. Very interesting presentation. There are some questions here we're going to discuss then at the end. So let's move to the second presentation. After this very interesting international collaboration from Norway, Liban, and I think the US as well, right, Nikolai? We are now going to Italy with Carlo, who is going to present with an industry presentation. So Carlo, you have the screen and you have the floor now.
Thank you so much. There are persons that in their life first because they learn to swim, and then they go to the lake or to the sea, and persons which are thrown into the water without having the opportunity to learn swimming. That's what happened to me, the second one. I was thrown into the Agile, not the principles, but the Agile framework in particular way during my last 2 years of the work. And so I tried to gather something out of this due to my impressions in this funny and stormy months. The idea was to reuse something that has been already developed in the past, and a couple of persons present of our mentors, the two main mentors present in this conference can remember very well two European projects, research projects, one named AMISA, one older named Sistest. And then they evolved during these times, and so it was possible to work on them and to evolve them in these years. They left a trace. The first trace they left, and it's quite recent, this is relatively new, it was not afforded in the two researches, but it relates to relationships, organizations. So living in a Scrum team. And so I thought that it could be, given that the Scrum team must be independent, self-capable, and complete. And so I thought it could be interesting to describe by the DSMs and to assess the team's capability to have a success by 3 dimensions. One is belonging to, so how much the person belongs to. Can be 0, 1, but can be also the percentage of time allowed to their weekly or sprint working time. Then the second time is competence. And competence plays a great role because in the team there must be all the competencies, and competencies come from history of a person or the companies. So there are persons who have owned because they practiced some competence areas, and so it's possible to have scales that relates to how much they know about a certain competence area. The third part, which is more a soft factor, is personal affinity. One team works well when people know each other, work well with each other, and this is quite relevant to me. So my idea is to prosecute on this type of reasonings and to assess in the different 4 or 5 Scrum teams that work into a program how they can interpret what are the dependencies and so on. This is just begun activity. But let's come to something which is a bit older. When we developed the AMISA project, we wondered what could be the adaptability to be introduced into the system architectures so that they could provide the maximum value to all the stakeholders through their lifetime. I think this question is still absolutely valid. The only thing that is changing in this question is that changes happens not only during the lifetime, but during development quite quickly. So why not reusing some of the concepts of AMISA that developed a lot of developed methodologies, different tools, etc. So I reused part of it, and also one book very well written by our coordinator Hafner Hengel, who did a great work to condense this work. And so what did we do? I worked on this in the last years after the end of the projects. And I reuse the part of simulations to estimate the ENPV, actual the expected net present value, alias the actualized monetary income estimation, for simulations that are intended as from 1 to 5 years ahead, and including especially focusing on the environmental adaptable architectures. This means that I work in the liquid food packaging area, and obviously we have already been thinking to and working on the environment, but in the last year there was an incredible acceleration. So it was possible to combine Monte Carlo simulation, DSMs, and Bayesian inference to foster the expected value based on the question that every consumer, and all of us are consumers, shall pose. Shall I buy a renewable zero impact package versus an old one? Another project a bit older was regarding the it was called SISTES, was regarding the verification, validation, and testing strategies using the historical project data, and the ER data mining and so on plays a role, etc., and providing stochastic estimates for cost, schedule, and technical performance risk reduction through a certain strategy. Once again, I think the questions are very well posed, still actual, but the VMV strategies continue to be updated at every sprint. So it's necessary to use part of this to re-update it at every sprint. There were a lot of, there were once again tools and methodologies to be used. And so I came to something what I call VX square, that is verification and validation effectiveness and efficiency. That is a way to re-estimate the efficiency of the verification validation strategy during the development. And so that was performed by DSMs. I already presented this to one of the previous conferences, but this work is ongoing. And this, for example, here I'm linking needs, system requirements, and test methods. And this evolved, this work evolved. We have also ongoing activities on this, which are regarding the implementations of Agile and their impacts on the systems engineering. So, how to see what to do with verification and validation in practice, pragmatically in every day, and those operations, we included those operations. We have a series of workshops planned for the next months. And the next MEA workshop, we will see exactly the problem of verification and validation in these times of the pandemic and of implementation of Agile principle and so on. So this is everything I wanted to show, and I think I stayed in time. It's clearly, and there are more open questions than proposals.
Okay, yeah, you're definitely in time, Carl. Thank you very much. Thank you very much for this interesting presentation. Let's move to the third one. And now we're going from Italy now here to Canada with Mitra Taragi, who is my PhD student, and they're supervised by me and my colleague here in the department, Danielle Imbu. That's a student presentation. She's going to talk a little bit about what we have been studying the last months. Keep it on. We have been talking the last months on the exploring the use of DSMs in her PhD project. So, Mitra, now I'll mute myself and you can talk now.
Hello, everyone. My name is Mitra Taragi, and I'm a PhD student here at Polytechnique Montreal. So I have created a mural for my poster, for which I'm sharing the link in the chat so that you'll have access to the poster through the mural. But anyway, I would be sharing my screen.
Mitra, can I ask, do you want us to interact with the mural or just view it?
It's just for you to view, to have access to details of the poster. But anyway, I would be sharing the mural through my screen. So just let me know if you can see the mural. Okay, so my presentation today is about application of DSM for the analysis of needs in UX design. Needs analysis is a major concern and also an important step in innovation projects, both for the organization that pursues business objectives and also the users whose needs need to be satisfied if the product is to be successful. Here in my research project, I'm doing an internship at a company named CN, which is one of the largest transportation companies here in North America. And I'm collaborating with the UX design team. Depending on the scope and complexity of the projects, different needs analysis methods could be applied. However, not all the existing methods could respond to the requirements and mandates coming from the UX designers who need to categorize and prioritize the needs and make the design decisions accordingly. We have used the cognitive mapping technique to develop and test a needs analysis method called needs mapping. Cognitive mapping has been already used in some organizations for strategic planning and decision making, the instances of which have been quite successful. This method is capable of showing the needs and their interrelationships and give it some sort of an all-at-once image to the UX designers, giving them the perspective to understand the needs and see how they have an impact on each other, so that they could contribute for decision making and prioritization. However, cognitive maps are quite complex structures, and we need a method to further analyze the data derived from the map, and that's how we came across the idea of using the DSM. So my main objective here is to consolidate a needs analysis methodology that not only clusters and groups the needs, but also is capable of help us in prioritizing the needs and based on their importance, weights, and impact levels. To help the UX designers in their decision making, and to this purpose, we are investigating the application of DSM in analyzing the maps. So, what is exactly needs mapping? Needs map is comprised of nodes and links, where the nodes are representative of the need, and the links are kind of representative of the connection between the two. So when A is connected to B, means that A leads to B, or A has an impact on B, meaning that there's some sort of causal relationship between the two. And in addition, we have used an initial clustering in our need maps based on means in theory called the Acv clustering, where we have made the distinctions by color coding. So at the high level needs, or our values come at the top of the map mostly, so shown by color green. The product attributes come at the bottom, and they are shown with pink, and the consequences come in between, having an intermediary role, meaning that the attributes would lead to consequences and consequences would lead to our values. In here, we have also used some sort of shape coding. So the squares and rectangles are the ones that are coming from the users, and the circles are the ones that are coming from the business and stakeholders. So we have kind of used this shape coding to make the distinction between the needs and requirements that are coming from different groups of people. So in here, we can see that some of these nodes have a lot of, like, so it means that, like, to address this value, we are going to, we need to address a lot of other consequences and product attributes. And there are some others that have a lot of outputs. So it meaning that only by addressing this one product attribute, we would have an impact on a lot of other consequences. And we have also shown constraints here in red, so that we can also have an evaluation of the level of impact of each constraint. In here, I have just created this matrix as one of the possible ways of using DSM in need mapping. So we have all the needs at the top and also on the left. When there's an X here, it means that we have put the outputs on each row and the inputs on each column. So it means that, for example, here F has a connection to B. And so one possible way is to create the clusters based on people's involved in the project. So in here, we have all the needs that are related to users, then the business, the product owners, and the designers. There might be even other possibilities to show the clusters like based on the Acv clustering. So having like the values at the beginning and then the consequences and then the attributes. So different clusterings could give us different information. But on top of all, we are looking for a way to find out the impact level of each of these needs. For example, in here, I know that B has an impact on H, but B itself is impacted by F and I and D. So technically H is not only directly impacted by B, but also indirectly impacted by other nodes. And my idea here is to find out a way, maybe combine this with somehow with subjective judgments from the team, or even coming up with some sort of an algorithm that could give me the impact levels on our final values for each of these needs and requirements. And to this end, our assessment of the potential of DSM for this purpose is preliminary, and I'm looking forward to receive your feedback and your comments in this regard. Thank you very much.
Okay, thank you, Mitra, for the presentation on time. Thank you very much. As Jakob said on the chat, since it's a student presentation, we also invite you to follow the link that Jakob's put on the chat for evaluating for Mitra's presentation. Okay, so thank you very much for that. So moving now for our fourth presentation of the session, it's once again a scientific presentation. From Denise Hunter, Bill Klinger, Carl Dister, and Tyson Browning. So it's Bill who is going to make the presentation, right? So you can now share your screen.
Okay.
And I give you the floor for your presentation.
Okay.
Hello, welcome to a DSM-based validation tool presentation for the leveraging of optimization of internal controls. Thank you to Tyson Browning, who was our mentor in this particular application of the DSM today. And our problem was to figure out a way to ethically balance the opportunities and risks facing organizations. Like the kitten in the basket, an organization is dropped into your lap as a lead auditor like Denise, or as a systems engineer like Bill or myself, Carl. And it's overwhelming because all these processes, all these AKA internal controls, are interrelated. And you have to figure out a way to manage all that. And that's very confusing. So our proposal was a very simple solution. Let's use a DSM-based validation tool. And our goal was to use an ordinary spreadsheet, not to have to invest in a lot of coding, and that spreadsheet would help us systematically understand how these interrelated controls work, whether you call it an internal control system as lead auditors, and auditors like Denise call it in the Coso framework, or whether you call them management practices or systems engineering processes from a systems engineering point of view. How do they all interconnect? So we used a simple spreadsheet and no macros. That was our rule. Simple M multiply functions and sum product functions and addition and subtraction. But first, let's take a look. What exactly is the Coso framework for those of you who are systems engineers? And Denise, over to you to explain that in the world of Coso, what that is.
Thanks, Carl. On the screen is the Coso definition of an internal control, and the operative words that I would like to point out are reasonable assurance, because that's really all an internal control can provide. And in order to mitigate corporate risk, the accounting and auditing professions often implement internal controls according to the Coso framework model. Screen, please. This is the Coso integrated framework. It consists of these 5 components on the screen, along with 17 principles, which we're going to talk about more in a minute, and then 81 points of focus. The key part about this internal control framework is that it's a system. It must work in concert. And further, within the 5 components, those 17 principles are also highly interconnected. So Carl, could you tell us the impacts of these connections based on the Coso DSM?
Sure, Denise. In the paper, we clearly explained from the ground up how we built this DSM, which is inputs and columns, feedback below diagonal convention. We wanted to capture the interrelatedness between the 17 principles, as you see on the rows and columns of this DSM. Let's take the first column, ethical commitment. How well an organization is doing ethically. Sure, it depends on how they design their technical controls. Item 1, like typical in COSI controls, validation, verification. But to really get at ethics of a company, the more important weighted controls are COMI is a 9, communications internally. MONC, how you monitor those controls to make sure they're being adhered to. These are much higher weightings, these 9s in these areas, than just something like technical controls. Technical controls are important in other areas, but not as much in ethical commitment. So we built this up from the ground using the N² diagram out of the COSI handbook and published literature in the field of auditing from the Coso framework. We put it together. Denise, as an experienced auditor, took a look at the 1, 3s, and 9s and made sure they were valid. And we used this, capturing all the lessons learned of decades of systems engineers and decades of auditors to ground this in reality of how these various principles are interrelated. So let's see how to use it in a simple spreadsheet for a case study. Denise?
Thanks, Carl. I led an audit on 1 manufacturing plant and 4 warehouses. And I'd heard that at one of the warehouses, the inventory manager was, his inventories ran very smoothly and he was always on budget. So I was very excited about seeing how those processes were working. One of the challenges that we had with our inventory system was how it handled discontinued product. It should have only allowed depletion of those SKUs or stock keeping units, but it allowed additions into those SKUs. So in order to mitigate that risk of people hiding product, we implemented some additional controls, one of which was that we had 3 independent counters counting the warehouse. Then once they had completed their independence, they went and reconciled all their worksheets until they agreed. We had the warehouse manager expecting to review the discontinued SKUs after the inventory had been processed to ensure that no product had been added. And he also was reviewing any SKUs that had over 1,000 boxes in it. And we also had our regional director who would randomly select 10% of those SKUs that had over 10,000 boxes, or excuse me, 1,000 boxes, and he would reconcile those to the sheets. We did our initial review of the inventory, and we came up with the fact that we felt there was a discrepancy of 36,000 cases. This wasn't a deep dive, it was just a cursory initial review. So I went to the inventory manager to see if he might be able to explain what that discrepancy was. He assured me that he could, but that he didn't have time. He had to go pick up his kids, and could we talk about it in the morning? I said, of course, yeah, have a good night. I'll see you tomorrow. But I didn't. He never came back. So then, of course, we did a deep dive. And once we were done, we identified that it had came up to about $500,000 fraud. But it was adjustment in figures. He wasn't stealing. We also identified that the warehouse manager was not performing those reviews of the discontinued SKUs or the SKUs that had over 1,000 boxes, nor was the regional director performing his additional review of those 1,000 SKUs with 1,000 cases. And I couldn't get the inventory manager to respond. When he finally did, he stated that the reason he had done what he had done was due to pressures that the organization had put on his role to perform his functions. The results of this audit were that the warehouse manager was demoted to a warehouse worker, the regional director was put on a performance plan, the compliance manager was terminated, and the warehouse itself was placed on a revolving 6-month oversight plan. Overall, the organization implemented some increased communications to all plants and warehouses regarding the importance of internal controls and ethics. And we also went out and retrained all our plants and warehouses on inventory processes and the importance of being ethical. Now, having given you that little story, I'd like to hand it over to Carl so that he can walk us through how we built upon the Coso DSM to create the Coso Validator tool. Bill?
Well, this is Bill, and I want you to know the objective of the validator is to reveal likely limits on the effectiveness of processes that operate in a system of systems. Among the columns in the table, the components and principles are those defined by Coso. The next 4 columns, all process-oriented, conform to the concepts and terminology in ISO 33020. Here, all the ratings are P, partially achieved, because the process attribute capability levels have all been set to an initial value of 50%, pending more information about the actual capability levels. The maximum process attribute capability is the key output of the validator. Carl, how does the validator work?
Bill, what we did is we tried to use very simple mathematics. The center of gravity calculation is at the heart of it, and that's been around since the Renaissance at least. The idea is that you take the masses times the distances, sum them up, and divide it by the total mass of the system for center of gravity. Well, we use the same principle for our DSM validator. The DSM strengths, the 1s, 3s, and 9s I showed earlier, that really is proportional kind of to the distance on the teeter-totter here from the fulcrum. And the weights are synonymous with the effectiveness of the internal controls. 100% is a very heavy, well-implemented control or management practice. A 0% would be a very lightweight, not very well implemented internal control, not very effective. So that's how we do the balancing here. And we sum that up in the spreadsheet, doing sum products and M mults of the rows and columns of the spreadsheet divided by sums. A very simple calculation, no macros needed. We put that all in the spreadsheet, and we're able to do the calculation using that DSM I showed earlier. No fancy programming involved. Bill?
Thanks, Carl. Corporate management had long believed that the 6 capability levels in the violet-colored cells had been fully achieved, with values assumed to be around 95%. However, Denise's external audit revealed that 2 new controls had utterly failed because employees did not implement them. The external audit identified 3 controls that were only 30% effective, allowing fraud to go undetected. The company's process for risk identification and ranking failed to anticipate the impact of a software glitch. Despite management's 95% confidence in 6 capabilities, the validator shows that the average value for all 17 principles was just 54%. Now let's examine the effect of 2 interventions made to improve the warehouse inventory situation. After discovering the employee misconduct, the firm invested $325,000 to improve their execution of 2 principles. Controls accountability. Look at all the actions taken in that green bubble. Also, internal communication, a significant push by the company. Yet, all that effort focused on 2 areas barely managed to raise the average value from 54% to 63%. Had the validator tool been available to management, they might have used it to optimize outcomes by adjusting combinations of other principles to yield greater gains. We've seen one case study in action. What have we learned, Carl?
Bill, what we've learned along the way after talking to Denise, who's an experienced auditor, and myself and Bill have seen different GRC tools out there. The current GRC tools don't capture this interrelatedness as well as we need. So that's why we want to embody the virtues taught in the DSM community. Here's 3 of them. Build on known scenarios, don't reinvent the wheel. We use the N squared out of the Economics handbook. We use the interrelatedness of principles in the Coso model, all based on decades of experience by auditors and systems engineers. Secondly, we're learning from the interconnectedness that the DSM show. And we're doing that using a simple spreadsheet. Sure, all models are wrong and only some are useful. But the importance is understanding the interconnectedness and not sub-optimizing. And then finally, appreciating the dynamics. The organizations change so quickly. We need tools that are fast reacting and easy for people to implement so they could keep up. And this DSM embedded in a spreadsheet with no fancy macros, basic mathematical calculations can keep up with the dynamic changes in organizations. So we look forward to your suggestions that you might have for the future for us applying this tool and any questions you might have.
Okay, thank you very much. Thank you for this very interesting, not only interesting, but very dynamic presentation where all the team was working, very original. Thank you very much for that. We are now moving for the last presentation before we move to our discussion panel. So I invite David Preston for an industry presentation now.
Right. Well, thank you and good morning, good afternoon, or whatever time zone you might be in. Thank you to all the presenters, doing a great job. And I appreciate you sticking around for our talk here. Trying to get rid of my video window. There we go. So we're here to talk about dependency and structure modeling in large scale aerospace manufacturing with really an ultimate goal of breaking the complexity curve. And I'll get into what I mean by that here in just a moment. But to kick off the presentation, I love this quote by Oliver Wendell Holmes, who is a Supreme Court Justice in the US from 1902 to 1932. And what he said was, "For the simplicity that lies this side of complexity, I would not give a fig. But for the simplicity that lies on the other side of complexity, I would give my life." And what we really think is that this quote really sums up what DSM and some other tools do for us in aerospace, is they help us peer through that complexity and get to simplicity and then go forward, improve, design, and manage these systems in a more effective way. And we're going to show you a little bit about that. So a little bit about Collinear Group first to kind of set the stage about why we're applying DSM and where. We're a Seattle, Washington-based consultancy established in 2011. We like to say we're a digitally powered consulting and professional services company with over 10 years as an industry service provider. What we have is 4 verticals in our organization: digital engineering, digital manufacturing, engineering and certification, and digital aviation. And I think many of you as DSM practitioners and systems engineering-minded folks would know is we have that broad application space and experience across the program lifecycle, and we feel that's really necessary to have all of those capabilities you see in the vertical combined with those capabilities in the horizontal space there. So we bring domain experience and expertise to those challenges unique to aerospace and defense. And I got a little bit of a hypothesis about that here in a second. So a little bit about who's presenting. So I'm Dave Preston there over on the left-hand side. I have Tim Cook in the room here with me. And then other collaborators for this conversation and presentation were Adam Bell and Carlos Mascura. So we have a broad experience base in a lot of domain, and we're bringing that forward by applying DSM. So what's going on in aerospace? We've heard from some folks about what they're doing in aerospace and defense. And I like to point back to this chart. It was commissioned by DARPA some number of years ago, over a decade, trying to look at why do each successive major platform advancement in aerospace continue to get more and more expensive. And you can think of cost and schedule along that vertical axis there on this normalized graph. Along the horizontal, you have one function of what they're calling complexity. So part count or source lines of code embedded in these technologies. So the blue is aerospace, goes up and up and up and up. In the green, you have automobiles. And what that's saying is that complexity is actually increasing while the cost is decreasing. In the red, we have semiconductors. So they've stayed relatively flat as each successive generation adhering to Moore's law comes out. So roughly their costs have been staying consistent. And just like everybody else, we're in this industry experiencing significant brain drain, both in our engineering and our manufacturing organizations, as well as in our supply chain. We have a dynamic and constrained labor market, and especially in the last few years, significant supply chain disruptions. But what we want to say is that this has pretty outsized impacts to aerospace, and I'll show you why in the next chart. The whole goal is to break this curve, though. We really have to identify, reduce, and manage the complexity to break this cost curve. And that's what we're here to talk about. But before I get there, let's hear from Norman Augustine. He was the CEO of Lockheed Martin in 1995 to 97, and he had a number of laws. And he said, if that cost curve continues, something like in the year 2054, the entire defense budget will purchase just one tactical aircraft. This aircraft will have to be shared by the Air Force and Navy 3.5 days each per week, except for leap year, when it will be made available to the Marines for the extra day. And jokingly, that airplane may in fact literally be made of money by that time. So that's a little joke we have here. But in all seriousness, this is important for the industry and all of the lives and people that depend on it for their livelihood, but also our defense forces out there doing work globally. So when we get into graph and network view of this complexity, we like to use this particular framing. This is a pretty notional chart, obviously. Along the vertical, we can think about number of parallel paths of work being done in manufacturing processes. So down on the lower left, we have things like widgets, toasters, tricycles, as you can see, cars, as you get more complex. Along the horizontal, we have number of connections or dependencies per task within these environments. So along this diagonal, it gets increasingly complex, right? So in this industry for over 20 years, we've heard a lot and applied a lot of technologies and methods like lean manufacturing and Six Sigma, and they're highly effective in getting that low-hanging fruit, we like to call it, in aerospace. However, you hit a barrier of effectiveness if you don't identify that complexity, reduce it, and then manage it from there. So what we want to say is these business as usual approaches won't work to get ultimately that goal to break that cost curve. And we like to say something like billions has been spent in aerospace defense on many inadequate methods and tools. Again, they have gotten some, results, but diminishing marginal returns is definitely at play in this industry. So as those dependency densities start to increase along that diagonal, we go from pretty linear impacts. Yes, you're making hundreds of cars at any given time, but in particular, those impacts can be linear in effect. As you get that dependency density higher and higher, all of those ripples spread out across these production systems very quickly, and something like a bracket that's late can have outsized impacts in these production systems and cause a whole lot of problems. So when we look at it from a process perspective, traditionally, we applied tools like Lean and Six Sigma, other simplistic kinds of metrics and measures, or orchestrating production through what is called waterfall scheduling, and many of you may be familiar with that. Those actions that are taken is things like improvement workshops and getting together tiger teams, quick action teams, or management by local objectives. An example of that might be something like job completions per day. What that really drives is poor behavior and drives cherry picking of work that may or may not be out of sequence and be globally optimal. What that can result in is, yes, again, you can capture that low-hanging fruit, but from then on, you get pretty incremental cost and quality gains. Any of these manufacturers would probably agree with that. But in some cases, that complexity actually increases because of that local optimization happening. I know that's somewhat of an esoteric concept, but it can happen where a small shop within these large production systems does things its way and it has a well-oiled machine. But if it doesn't aid in the global, it won't have the effects we're looking for. So the cutting edge that we're applying in industry apply technologies like DSM, network analytics, and advanced scheduling in coordination and integration with one another, along with a host of methods and just good old hard work out there on the manufacturing floor. Those common actions, what that gets for us is prioritized work assignments, strategic surpluses, otherwise known as buffers, to absorb those impacts and that variability. And we get targeted improvements to address that global complexity. An example of that might be improving highly connected job sequencing first and repeatedly over time in these production systems. What we can get out that, and we've experienced in our several decades of applying these methods, is stepwise factory flow reductions. That's pretty significant when you're talking something the size of a 737 or a 747, or some of these military platforms like an F-15 or a bomber or an F-35. You can get pretty significant cost reductions, but also improved predictive ability when you see these impacts that might be coming your way, like part shortages. Well, zooming out, when we look at it from an ISA 95 perspective, which is the International Society of Automation, they have a host of standards that they've put out to aid not only aerospace industry, but other manufacturers in developing and integrating these enterprise control systems. So looking at it from that systems of systems perspective, this is one view of the 5 levels of what ISA 95 describes in these systems. So the topmost being business planning and logistics, long range, ERP system, supply chain orchestration. As you go down, that complexity increases, but the more you dial that in and get that highly refined, the benefit increases as well. But down at the bottom, especially in aerospace, when it hits that actual production process, if you're not modeling and orchestrating production in an efficient way, that's where really bad things can happen. And right now, in some cases, you have very rudimentary approaches to orchestrating production, and you have some that are more advanced. What we're doing is we're taking DSM and injecting it into the planning and scheduling. We've heard some about project and process networks during this conference, but what we're doing is we're using DSM to help define dependencies, analyze relationships, identify those weak points, and prioritize the work. DSM is a key technology to perform all of the actions above. And a little example that we can see below is it's pretty sizable, but this is only one chunk of one particular platform and its associated precedence network. Going back and forth between these few views aids a lot in how to design, improve, and manage these complex systems. Not only that, in this case, this DSM, I'm not going to zoom in on it because it is it's a proprietary details in there, but associated to the DSM, so from 2 relationships, we have actual experienced manufacturing data. And so when you go to cluster and identify opportunities, you look at historical information about what might have already caused issues in these pre-existing production systems. So what do we do with that from a process perspective? Well, we take those inputs, which are things like the overall factory architecture, what positions are there, how many models of a particular product, take process architecture. We capture a lot of manufacturing experience, so it's a form of knowledge capture, the task sequencing and other various manufacturing constraints, and we produce that planning model. We integrate DSM with an advanced scheduler with technology developed by Stotler Henke, one of our partners. And we get out of that a baseline plan, potentially re-optimized from its existing baseline plan. We drop that in a configuration manager, and we get into execution and live model use. We heard yesterday about, it's nice to have a model, and we very much use that same adage from the previous presenter, all models are wrong, some are useful. But when we get it useful enough, we can use it to actually orchestrate and provide value to these production systems. One output we get out of that are network insights and dependency analyses. And then we can get recovery planning as well live during the experience disruptions that these production systems often have. And like I said, we need to be agile and orchestrate production around these disruptions. Even a bracket, like I said, can cause a significant amount of issues. So we got to keep production moving, got to understand what we can do next. And that's what recovery planning does for us. So what are our conclusions and recommendations? Well, Lean and Six Sigma, we like to think of them as derivatives of the Toyota production system, and they haven't saved aerospace. They've been essential. They're kind of like table stakes in a poker game. You got to do them, but if you don't get past that complexity and use technologies like DSM, they won't get you there to complete success and break that curve. The key with these technologies, DSM, network insights, and advanced schedulers, is where to focus, design, manage, and improve these systems. It's all about focus, peering through the complexity. DSM, we believe, must be a part of that solution to reduce and manage complexity in A&D, not only in manufacturing, but we have applications in the test and certification phase of these program life cycles and moving into design engineering as well. Of course, we'd like to come back next year and share further what the developments are in this saga. And we appreciate your time. And if you get interested in more, feel free to reach out at any of the information I show here. And with that, I'll turn it back.